Hello and welcome to Module 3 of HVAC 101, Heating Appliances. In the HVAC industry, one of the main services we provide is comfort. We do so by installing and maintaining the equipment that heats and cools customers' living and working environments. In heating, we achieve this goal by adding heat to the conditioned space when it is cold. The way we accomplish it today is through controlled heat transfer using various heating appliances. Fundamentally, all the appliances are the same. They are designed to produce heat in one way or another and deliver it to the conditioned space. All appliances have a heat producer, a flame sensor, a heat exchanger, a method of protecting the equipment from damage due to high temperature and/or pressure, a method of disposing of combustion gases in a safe manner, and a method of distributing the heat produced. In heating, the main appliances we use to add heat to a conditioned space are as follows. Warm air furnaces. A warm air furnace uses air to carry heat to the conditioned space. Steam boilers. They use steam. As you remember in Module 1, that's latent heat to deliver heat to the conditioned space. The last appliance are forced hot water boilers. They use hot water, which is sensible heat due to no change in state, to deliver heat to the conditioned space. All these appliances are designed to work with various fuel types. The main fuels used today are oil, natural gas, and propane. An appliance that utilizes oil as its fuel source is distinguishable by the burner that is used to deliver the flame to heat, whichever medium is being used to carry heat, such as air, water, or steam. There are different types and designs of oil burners, but they all work on the same principle. A gas-fired appliance uses a manifold to heat the water, air, or steam, whichever is being used to carry the heat. Again, there are different designs and types of gas manifolds. We are not going to cover how gas manifolds or burners function. For now, it is important that you are able to distinguish the difference between an oil-fired appliance and a gas-fired appliance. The two furnaces shown have their burners mounted behind the access panels. The easiest way to tell the difference between a gas or oil appliance is by the fuel line going to it. A gas appliance will usually have steel pipe feeding the gas. Also, there should be a drip leg, shown in detail on this slide, installed in that steel pipe that feeds the gas to the burner. An oil appliance will have a smaller copper line feeding oil to its burner. The size of that line is the size of the pipe that you were flaring in the lab. Now that we have looked at the different fuels and how to distinguish between oil-fired and gas-fired appliances, let's take a look at the types of furnaces and their common basic parts. Furnaces heat a conditioned space by convection. Furnaces use ductwork to deliver the heat it produces to the conditioned space and bring the cooler air back from that space to be heated. Furnaces have a supply duct and a return duct. The supply duct is the one that delivers the warm air to the conditioned space. The return duct is used to bring cool air back from the conditioned space. All furnaces have a combustion chamber, a heat producer, a flame sensor, at least one heat exchanger, a blower, a filter, a means of protecting the heat exchanger from too high of a temperature, a way to ensure that cold air is not blown into the conditioned space, and a method to dispose of the combustion gases. This is a picture of a condensing furnace. It has two heat exchangers. On condensing furnaces, you will find a means of disposing of the condensate that is formed due to the second heat exchanger. This usually is accomplished with a small plastic pipe which runs to a drain. These furnaces cannot be vented into a chimney. They utilize a CPVC, basically plastic pipe, to vent its combustion gases to the outdoors. These furnaces are very efficient, and they can take most of the heat out of the fuel they are burning. A non-condensing furnace can be vented out a chimney. It will utilize a metal flue pipe to vent its combustion gases. Since they use only one heat exchanger, they will not have a pipe to drain condensate, and they are much less efficient than a condensing furnace. The easiest way to tell the difference between these types of furnaces are a condensing furnace will have a drain and use a plastic pipe to vent its combustion gases, whereas a non-condensing furnace will use metal pipe to vent its combustion gases, and it will not have a drain. Furnaces come in four configurations. You have a downflow, also called a counterflow, horizontal, upflow, and multi-position furnaces. This refers to how the air to and from the conditioned space enters and leaves the furnace. When choosing which furnace to use, the position of the ductwork will be the main determining factor. A downflow furnace has supply ductwork at the bottom and return at the top. An example of where you might see a downflow furnace would be in a mobile home, in that it has ductwork in a crawl space below the home, and the furnace is installed somewhere in the living space. A horizontal furnace has the supply ductwork attached to one side and the return ductwork attached to the other. An example of where you might see a horizontal furnace could be in the attic of a home. An upflow furnace has supply ductwork attached to the top and return air attached on the side at the bottom of the furnace. An example of where you might see an upflow furnace could be in a home where the furnace is installed in the basement and the ductwork is above the furnace. A multi-position furnace is built with a few minor adjustments. It can be used in many different positions depending on how the ductwork is installed. Let's take a moment to go over how the heat is actually taken from the fuel and transferred to the conditioned space. This you may better understand by doing heat transfer module 1. As the flame burns, it radiates heat to the heat exchanger. As hot exhaust gases move through the heat exchanger, they transfer heat by way of convection and conduction to the heat exchanger surface. Then the heat exchanger surface transfers heat by way of convection and conduction to the air in turn, which transfers its heat to conditioned space by way of convection. So all three of the methods of heat transfer are being used. There are three types of boilers that are used to produce and deliver heat to a conditioned space: forced hot water boilers, steam boilers, and boilers that can be configured as either steam or forced hot water. Boilers can be constructed of cast iron or steel. Pretty much all boilers have similar features. Just as a furnace, they have a combustion chamber, heat producer, flame sensor, a heat exchanger, a method to protect the equipment from too high of a temperature, a method of disposing of the combustion gases. Boilers also have a means of protecting the boiler from excessive pressures and from the water level in the boiler becoming too low. A forced hot water boiler is designed to heat the water, and the energy from the water is transferred to the conditioned space. Since there is no change of state, only a change in temperature, this type of heater energy uses sensible heat. So for every pound of water in the system dropping 1 degree Fahrenheit, it will deliver 1 BTU of heat. A steam boiler is designed to heat the water to its boiling point and then change the water to steam. The main way the heat is transferred to the conditioned space is by latent heat. As steam cools, it condenses back the water and releases 970 BTUs for every pound of water condensed. Boilers can be either wet-based boilers or dry-based boilers. What that means is that with a wet-based boiler, the combustion chamber is surrounded by water. With a dry-based boiler, the combustion chamber has no water around it. These are examples of wet-based boilers. Notice how the pipe goes into the bottom of the boiler, or you can also maybe see a drain valve that is evident on the bottom of the boilers. These are examples of dry-based boilers. Notice how the pipe goes into the boiler above the burner, or there may be a drain valve evident above the burner. To tell whether a boiler is a steam or a forced hot water boiler, it is actually very easy. If you look at these two pictures, you should be able to see some very noticeable differences. One of the first things you should notice is that a forced hot water system will always have an expansion tank. It is needed because the entire system is filled with water. That means it not only does the boiler contain water, but also all the piping is full of water. This gives the water a place to go when the water is being heated and expands in volume. Forced hot water boilers also have circulators. Circulators create a difference in pressure to help move the water around the system. Another difference you will notice is that a steam system has a water level sight glass, or a gauge glass, as it's sometimes called. A steam boiler must have room for the water in it to boil, to change to steam, so the proper level of water must be maintained. If the water level is too high, there will not be enough room to properly produce steam. If the water level is too low, the system is at risk of not operating properly. A forced hot water boiler does not have a gauge glass. The system is completely full of water. Also on a steam system, you will find a pressure limit control with a pigtail. It's a very distinctive item. A forced hot water system will not have that control. The common parts you will find on a steam and forced hot water boiler are a boiler drain, pressure relief valve, low water cutoff, a pressure gauge, and a high limit control. All of the parts except the boiler drain, pressure gauge, and temperature pressure gauge are safety devices. The safety devices are used to ensure the boiler operates in a safe manner. The boiler drain is there so you can easily drain the boiler of water if the need should arise. The pressure relief valve ensures that a boiler will not build up too much pressure and blow up. It is designed to open and relieve pressure if the pressure in the system goes too high. The temperature and pressure gauge is used to determine the conditions in a forced hot water boiler. The pressure gauge is used to determine the pressure of a steam boiler. The low water cutoff is installed on all boilers to shut off the burner should there be a loss of water in the system. On a forced hot water system, we have a high limit control called an aquastat. It ensures that the water temperature in the boiler does not exceed a certain temperature. When the water reaches the set temperature, the burner shuts off. Until the water drops in temperature, then it'll restart. The pressure control is a limit control used on a steam system. It ensures that the steam boiler does not build up too much pressure. When the pressure reaches its setting, the pressure control will shut off the burner, and once the pressure drops in the system, the burner will restart. All boilers and furnaces have ratings. The ratings are on a plate that is attached to the boiler or furnace. If you look at the ratings plate, you will notice that different measurements are used. MBH, it means just 1,000 BTUs per hour. Remember, a BTU is a British thermal unit. BTU hour is the amount of BTUs that can be produced in 1 hour by the heating appliance. If you look at the picture on the left, which is a boiler ratings plate, you will see that the water, MBH, which is 6 lines down, is 664, which means the boiler configured as a forced hot water system will produce 664,000 BTUs in 1 hour. If you look at the picture of the furnace rating plate, the gas input in the furnace rating plate is 75,000 BTUs an hour. To convert to MBH, you need to divide by 1,000. That would equal 75 MBH. The boiler rating plate also gives information about its maximum pressure ratings. That's the highest pressure the boiler should have in it. Both rating tags provide valuable information about the heating appliances they belong to. Take a minute and study them. This is the end of Module 3 for HVAC 101. Thank you very much.